So now, as I replaced I alpha, similarly, I'll be replacing now, as we have seen here, replace A by I alpha. Now let's replace by minus I alpha. So again I say replace A by minus I alpha. So let's define that equation, which will be easy for us. So I say this equation as my equation number A. So where I replaced A by in equation number A, again I say here, say replace A by minus alpha in equation number A. So let's start. After replacing, I get e raised to minus alpha x, which is equal to summation of minus infinity to infinity minus 1 raised to n. Here it becomes sine hyperbolic. Now it is minus I alpha into pi, and then which gets divided with pi into. So again in the place of a square, when I replace minus alpha square, so that becomes as minus alpha square plus n square, and then minus alpha plus in into e raised to I nx. Now students, that's all those. So again I'll be using sine of minus theta is minus sine theta, so there will be a minus sign outside, and also I. So e raised to minus I alpha x gives me summation of minus infinity to infinity minus 1 raised to n minus I outside and sine alpha pi, and this I get as minus I alpha plus minus in into e raised to I nx, and then it gets divided by, I say its whole get divided by pi into minus alpha square plus n square. So finally I can say e raised to minus I alpha x, that is equal to summation minus infinity to infinity minus 1 raised to n. Now this minus I, let's multiply this minus I inside, so that becomes plus I square, which will be giving me sine alpha pi is there. But here when I multiply this minus I becomes plus I square, which again gives me what? Minus alpha, and here minus I square, which is nothing but plus n e raised to I nx, and the whole it gets divided by pi into minus alpha square plus n square. So that is exactly what I got. So let's define, it will be easier for us. So I define this as equation number B, I define this as equation number C. Now let's go further. So we wanted to prove, if you see what we wanted to prove, so we know students, we had substituted A as I alpha and minus I alpha, which will be giving me cos alpha x and sin alpha x. How it will be giving me, let's see. So now, according to equation number B and C, suppose I write a formula of cos alpha x. So cos alpha x in the exponential form is e raised to I alpha x plus e raised to minus I alpha x, and this gets divided with 2. Now students, so you know very well that we have e raised to I alpha x and e raised to minus I alpha x. If you see it very well, what we need to do, we just need to add it. So I just say 1 by 2. Now summation, please have a look on my equation number C and B. So my summation will be common, minus 1 raised to n sin alpha pi will be common. See, I'll just take that in addition. So minus 1 raised to n sin alpha pi summation, and then pi minus alpha square plus n square will be common, e raised to I nx will be common. So just we need to add this term, this bracket and this bracket, which will be giving me, when I add it, it will be minus and will be cancelled, and it will be finally giving me what? Minus 2 alpha.